So in this example we are going to calculate current I3 by using current division rule. Okay, so in previous example what we had two resistors. Now we had three resistors in parallel. Now I want to find the current of I3 by using current division rule. Okay, so first of all we should know the question, no? Okay, I want to find the current division rule. I want to find the current I3 and be using current division rule. So what current division rule says that now, if we already know that if currents gets, suppose I am denoting this current as I, now it's going to divide into this I1, and this current will divide into I2. This particular node, at particular node, this I1 gets divided into I1 and I2. Now this I2 will coming into this node. Okay, now it's going to divide into this path I4 and I3. Okay, fine. So what we did now, we just gave the name to the all currents, whatever currents were dividing. So I current is incoming at this node and it's dividing to I1 and I2. Okay, and I2 is coming at this node and it's dividing into I4 and I3. Okay, so I know the current of I1. Okay, so for knowing this I3 we should know this I1 I2. Okay, for at least I should know the I2. Okay, first of all, because this I2 will coming to this node and gets divided. Okay, so I want to find I3 by current division rule. So I will apply I will find this I will apply this current division rules at this node, and I will find I3 by using current division rule. Okay, so I want to find I3. Okay, I want to find I3, and how will find that? Now the total current is that I2. Now this I2 gets divided into I4 and I3. Okay, now this I1 is not going to divide it. Okay, so now total current is for this node is I2, not I. This is the very fundamental step. We should, if you find a difficulty to identify this, so that means you will be not able to solve this problem. So you should identify which is total current, because this node, this I2 gets divided into I4 and I3. So the work of total current is now going to do with this I2. Okay, it's all about now I2. It's not about I1, because we are applying current division rule at this particular node. Fine, because now this I2 will do work as total current. So what is my total current for this node now? That is I2. That is this current, because this current is coming and gets dividing. So that's why we are applying current division rule. That's why name is suggested as current division rule, because currents get divided into two paths only, particular. Okay, so now I am applying current division rule I2, and I want to find current this I3. So I should take opposite resistance, that is 5 ohm. Okay, and this summation. Okay, because I4, this I2 currents divided into I4 and I3. So I should take another resistance, that is another resistance I5, because I2 divided into I4 and I3. Okay, so this is the more crucial step. Okay, you should be able to identify this, which is current is going to divide. Okay, so now, and this is the similar to the previous question. Now I don't know what is I2. Okay, now I don't know what is I2 because I don't have value. So how should I identify, how should I calculate I2? Okay, how should I calculate I2? So I can calculate I2 by various steps. Okay, so for calculating, because calculating I3 I need I2. Okay, so how will I calculate I2? So I will calculate I2 by current division rule also only. Okay, so how can I calculate I2? Because if I get I2, I have to just simply replace I2 in this equation, and I will get a value of I3. Okay, so for finding I2, what I will do, I will equivalent this circuit 10 ohm, this I, don't change your current directions, and this I coming into this node and getting dividing into I1 and I2. Okay, so the current in this branch is I2. Okay, so what will I do now? This I will do this equivalent resistance. I will do, because applying current division rule on this node, I want just two paths, because I should divide into only should two paths, I1 and I2. It should not divide furthermore. Okay, so what is the equivalent resistance? 5 into 10, 15. This is the most fundamental example of current division rule. If you are able to solve this example, then you are able to you will be able to solve all kinds of example of current division rule. So this is the most fundamental example of current division rule. So this is the, what is the 50 by 15. Okay, so what is the, it's simply roughly 3.5 something, 3 4 40. Okay, 3/4 something that. Okay, just revisit that calculation. So I will, okay, I should do this calculation that will help us. 50 so okay, so 3.34 something, so that is roughly 3.34 something. Okay, so the value of resistance is 3.4. okay, just I am assuming that I had done calculation very correctly. And now I want to find I2. Now we have two resistors, because now I can find I2. In previous case, how could have not find I2? Because this I1, this I gets current divided into I1 and I2, and further I2 is gets divided into further resistance. Okay, so I should know, I should have just two paths. Here how we represent. Okay, so now I want to find I2. So what is the total current now? Total current, and what is the opposite resistance? 10 ohm, because I want to find the current that is I2, and total resistance 3.4. okay, so total current is that I has 10 ampere, 10 into 10, 13.4, that is 100 by 13.4. okay, so that is the value of I2. okay, so now we got this I2. Now we can apply the current division rule. The same, whatever we were explaining, that is I want to calculate I3. So what is the value of I3? That is total current gets divided into I4 and I3. So I should know, now I know the I2, that is 100 by 13.4. I should replace it, 100 by 13.4 and 5, 15. okay, so the what is the catch here now? We should identify where we have to apply the current division rule correctly. Suppose if you applying this I2, you will taking, if you don't know the correctly now, if you this total current you are taking this I, that is simply wrong. Here we can't apply this kind of current division. We can't apply this. Okay. So you should identify which current is dividing into some paths. Okay, I2 is dividing I4 and I3, and it should be divided into only two paths, not more than that. Okay, so for that with this calculation, for applying this current division rule now, we should equivalent this two resistance in what were in parallel, and we calculate its equivalent resistance. Now this I current gets divided into I1 and I2 only. This I2 is not dividing further. Okay, that's why we are calculating this. Okay, this is how we apply the current division rule.